So these are going to be some of the problems which were discussed in the revision course. I'm just sharing it here. So this revision course is majorly designed keeping in mind aspirant who has completed the 11th and 12th course in physics, the regular course in physics, and wants to fine tune the preparation for main and advanced level problem solving. It is open for everyone course, but it is a closed community course. It is not there on any social media platform as such. I have kept it limited to only those aspirants who will be part of the closed community which I have created. And it is open for anyone who is going to be appearing for 2023. You can be part of that particular course. There is no cost for this particular course, but then you can see the quality of discussions which are going to be happening. It's just designed considering the recent trends and difficulty levels of competitive exams of the last 2 and 3 years. So this course is designed keeping a 11-week structure in mind. In fact, you can see a few of the problems, particularly which I'm going to be sharing it. A few problems. I'm not doing this on YouTube so that it doesn't keep a distracted environment. So in YouTube means you click some video, there will be so many suggestions which will be coming. So I do not want you to be distracted through ads, and then in between YouTube ads are one big distraction for that matter. Right, so you can just see how these questions are being discussed, and I have shared my WhatsApp contact number in the beginning of this particular video. Also, my WhatsApp contact number is there in the description. You can get in touch with me if you want to be part of this particular free of cost course. But just that if you want to be a part of this particular course, you need to help me out in reaching out to students, because I am not doing this on YouTube where I can reach out to so many students. Only a few discussion points I'm putting it on YouTube for reaching out, so that spreading out does happen. Majorly it could only happen in the initial stages. Only those aspirants who actually feel the need for this particular course, you can spread on this particular word through word of mouth. And word of mouth is one of the best way of organic way of reaching out, not just through ads. And in fact, I don't have the kind of budget to even go for ads and all that. So word of mouth is what is going to be helpful in spreading out this particular thing. So to be part of this particular course, you just have to kind of give reference to two other aspirants, and you can just very well be part of this particular course. There will be daily problems on a daily basis, which I would be discussing, like every day, at least half an hour of crisp content where students usually make mistakes. So kind of you can see the discussions which are happening. I'm just sharing it out over here. So you can go through it and you can take a call. And once you're going to be part of this course, you will see the kind of quality discussions which happen. So any serious aspirant will be immensely benefited out of this particular course. I can say that without an iota of doubt, that the quality of content for main and advanced, you will get full-fledged concept gaps. Everything will be fulfilled, but ensure that from your side also you're going to be putting in efforts. See, the thing will work out only when efforts are going to be happening both ways. See, one way effort is going to be leading to a kind of dead end. Right, only you are putting in the effort, there is no guidance, you might be beating around the bush. In fact, that is what actually happens if someone is preparing without a guided approach. And only if I am going to be putting in the efforts and aspirant side there is no effort, that also doesn't kind of be fruitful outcomes don't turn up on that area as well. So all the very best. You can just go through the content and take a decision for yourself whether you will be benefited out of this or not. So all the very best, and hoping to see you on board for this particular revision course for 2023. Bye. See you in yet another video. So you can just go through the discussions from the revision course which I am sharing out over here. Right. Now look at this particular question. So here this is a very interesting scenario. See, after analyzing this particular scenario, I will also give you yet another question based on a similar idea. So when you have like multiple blocks in contact with a wall where friction is present, you need to carefully think and analyze. So if you look at this particular question, it says that the wall is smooth. So between A and wall, there is no friction, but there is friction existing between the blocks A and B, which are in contact. Now the question is the friction on B due to A in equilibrium. Now I would say that you try to think and analyze. Okay, the question, the friction on B due to A in equilibrium, and look at the options: upward, downward, zero, and fourth option says the system cannot remain in equilibrium. So how to analyze this? You make the FBD of block B and FBD of block A and see what is going to happen. And note that there is no friction from the wall. So I'm going to be taking this up for discussion here. So if you're going to make the FBD, now let me show block B like this and block A over there. Now on block B, there is one applied force like that. There will be normal contact force exerted by A on B. There will also be normal contact force exerted by B on A. And there will also be normal contact force exerted by wall on A. Now all these normal contact force values will be matching with the value of applied force because A and B are not moving in the horizontal direction. So now if you are going to think about this carefully, look at block A and block B. Its own weight is trying to pull both the blocks in the downward direction, and there is no friction from the wall. Now suppose say if we start from block B, its own weight is acting downwards. So if you try to think that, okay, maybe friction between A and B is going to try and prevent B from going down, and if you assume upward friction on B, then B will exert a downward friction on A, and weight of A is acting downwards. So there is nothing to keep block A in equilibrium because in the vertical direction, both the forces are in the downward direction. Now, if you assume the other way around, if you start from A, so if you assume weight of A is in the downward direction and friction force acting on A from B is upwards to prevent A from going down, and friction force acting on B that is going to be in the downward direction exerted by A on B, action reaction pair, and weight of B itself will be acting down. No, there is nothing to prevent B from going down because the net vertical force on B is clearly downwards. So whatever happens, this arrangement of both the blocks A and B, that cannot be in equilibrium. So answer for this question is going to be D. So this much extent is what you would be required to analyze in a JEE main or NEET scenario. Now, if you let us try to dig a little bit deeper. Suppose say if I ask you the question, what is going to be the direction of friction force acting on block B? It is known to it is not in equilibrium. Okay, let it not be in equilibrium. Now can you try and predict what will be the direction of friction force acting on block B and direction of friction force acting on block A? Okay, so you can clearly think that there should be in opposite directions. Now let me give you another scenario. See, this is a very interesting case to analyze. Imagine there is a ground, horizontal ground, and there are two blocks like this, A and B. Let's say A is a 2 kg block and B is a 3 kg block, and some coefficient of friction exists between the two blocks. Let's say it is 0.4, and the floor is smooth. Let me consider a scenario like that. There is no friction from the floor, and there are applied forces on both the blocks A and B. So on block A, let's say there is an applied force of 20 Newton, and on block B, let us say there is an applied force which is 30 Newton. So greater force is applied on block B now. Now in this scenario, can you try and predict what will be the friction force acting between the two blocks A and B? Floor is smooth. Right, I would suggest you to pause and analyze this scenario. Right, now I'm going to be taking this up for discussion. Now note that for a moment, just forget about friction. Assume that the contact between A and B is also smooth. Then this applied force of 20 Newton will create an acceleration of 10 meter per second square in 2 kg block. And this applied force F2 will also create an acceleration of 10 meter per second square in the 3 kg block towards right, if friction was not there. Now, common mistakes which students tend to do is, see, there is a greater force acting on block B. So on block B, friction must be towards left, and on block A, friction must be towards right. Like that, they might tend to think. But you must not go about thinking just based on values of applied forces. See, what is the role of friction? So this is a very beautiful scenario which arises when you apply forces like this, F1 and F2 values. See, what is the role of friction? Friction will try to prevent relative motion between the rough surfaces in contact. Now, the external force which is applied, that is creating an acceleration of 10 meter per second square if there is no friction. And F2 also creates 10 meter per second square acceleration in block B if there is no friction. So without friction itself, if the surfaces were smooth, there is no relative motion happening between A and B. A also goes towards right with 10 meter per second square. B also goes towards right with 10 meter per second square. So although the surfaces between A and B are rough, there will be zero friction acting between A and B in this case, because there is no need for friction. Anyway, there is no relative motion happening because of the externally applied forces which is trying to cause motion in the two blocks. So this is a very important aspect, role of friction. It is to oppose relative motion between the blocks. And since if you assume A and B to be smooth surfaces over there, and as such there is no tendency of relative motion, both the blocks move with 10 meter per second square, friction will be zero. The same thing will happen in the case of this vertical arrangement as well. See, whatever might be the value of applied force over there, suppose say the surfaces all are smooth, acceleration of B will be g downwards, weight of B divided by its own mass, acceleration of A also will be g downwards if there is no friction anywhere, I'm saying. Now there is roughness between A and B. So now I'm asking you, what is the friction direction acting on A and B? The answer would be there is no need for friction, because both A and B are going to move down with acceleration of 10 meter per second square, and friction between A and B is going to be zero. So in this arrangement, both the blocks will move together as one unit with g acceleration downwards. Okay, anyway, those things are not asked in this particular question. So since I'm analyzing all those things, I have put, right, this is also a very important idea for advanced. Right, okay, so that's about this particular question.